Good afternoon, students. Welcome to Analytics Powered Virtual Interactive Class. So, how are you all? Hope all of you are doing great. Wow, very good. So, in our today's class, we are here with a new topic of science. The chapter we were discussing in our previous class. Can any one of you tell me which chapter was that? Very good. Particulate nature of matter, right? So, in our today's class, we are going to discuss the next topics of that chapter. Okay? So, shall we begin? Very good. So, there is something written in the screen. What is it? Can you tell me? Very good. There is this one question. What is it? That what decides different states of matter? So, in our today's class, we will try to find that. Okay. So, let's start. See, here is one boy, and in front of him, there are some iron paper clips. And with the help of one big magnet, he is trying to do some kind of experiments. Okay. So, he is bringing the magnet closer to the paper clips, isn't it? And by increasing or decreasing the distance between the paper clips and the magnet, he can or we also can observe different results are getting, right? He is getting different results. Let's see again. Distance between the iron and the magnet was less. All the paper clips got attracted towards the magnet. And when he increased the distance between like magnet and paper, fewer magnet fewer paper clips were attracted to, and when he increased the distance objects more, then none of the got attracted, right? So from this we can say, sir, there was strong attraction. Okay, so this kind of strong attraction observed in solid substances. In the next, when the distance was a little bit more, then attraction, and this kind of we observe in liquid. Okay, and clear everyone? Then when the distance was maximum, then the attraction was very weak attraction, isn't it? So this kind of attraction we usually observe in gaseous substances. Okay, so whenever I am talking about the distance, about which substances am I talking about? I am talking about their constituent particles. Okay, the constituent distance between the constituent particles, they differ. Okay, so two constituent particles is highest, then comes liquid, and after that attraction we can observe in gaseous substances. Clear everyone? So from this we can say the strength of attraction particles decides the different states of matter. Very important line, that the strength of attraction between the particles, okay, that decides the different states of matter, whether the matter will be solid or liquid or gaseous. It is decided by the attraction force between the particles or the constituent particles of that substance. Clear? So the attraction, I hope all of you got it. Then we will learn about something new about our ancient India. So our scientific heritage, like in ancient India, around like 26,000 years ago. Okay, so 26 2600 years ago, there was this saint called Acharya Kanad. Okay, so he was a philosopher as well as a scientist, as well as what? As well as a sage. And there is this important of atomic theory. So we know him as these roles. Okay, and atomic theory. Who? Acharya Kanad. Okay, Acharya Kanad, he was the father of atomic theory when? In ancient India. So what happened? He used to go to the houses, different houses in the village, and he and collect something to eat. So what happened? One day he was going through the village, one house, and give me so gave him some rice. Okay, so he collected those and he went wherever he is staying at that time. And now he is thinking that the which particles or which thing constituted. Okay, so to check that, he did what? He broke that rice into smaller pieces. Okay, like this. And he also started to grind it and make smaller pieces of that rice. See, like this. So from grinding the rice, he got very few or very tiny small particle like structures. So from this, he concluded that this kind of small particle like structures are present in every material which is present around us. Okay, and he named them as Paramanu or atoms, which we call nowadays. Okay, so he was the one who first observed these things like this Paramanu or atoms, and his observations he also wrote them in a book. Okay, he whatever he observed, whatever he concluded, he everything he wrote in where? He wrote about this in the Vaisheshika Sutra. Okay, so this line is also very important, that whatever observations he had, he wrote about them in where? In Vaisheshika Sutra. Clear everyone? So here comes our first question. Let's see what the question is. The different states of matter are determined by the options are there. Option A, particles. Option B, size of particles. Option C, strength of particles. D, number of particles. So I am giving you the timer. Try to answer everyone. Okay. So I am telling the question again. Okay. The different states of matter. Different states of matter are determined by which thing? Option A, color of particles. Option B, size of the particles. Or option C, strength of attraction between particles. Or option D, number of particles. Which one will be the right answer? Tell me. Is it color of the particles or size or the attraction, strength of attraction between the particles, or will it be number of particles? Which one will be the right answer? How we determine different states of matter? And with that your time is up. Let's see how many of you have given the right answer. Very good. So many of you have given the right answer. So let's discuss the question. So as we have discussed earlier, the boy, he was bringing the magnet near or little bit far from those iron paper clips. So whenever he was bringing the magnet near the iron paper clip, all of the paper clips were getting attracted towards the magnet. And when he was decreasing the distance between those things, the attraction force became lower or lesser, isn't it? So in case of solid, liquid or gaseous, the particles, they also feel some kind of attraction force towards each other. Okay, so the strength of attraction between those particles or the constituent particles, this is what defines or determines that what kind of substance they will make. Okay, so in case of solid, the attraction force is something, then in case of liquid something, and then for gaseous it is something. So the main thing which determines it is the attraction force between them. So our correct answer will be option C, strength of attraction between particles. Clear everyone? Very good. Now we will observe another small activity. So before that, there is this little girl, she is reading something and she wanted to bring one pen out, but the box or the pencil box got slipped from her hand. Okay, so some solids soft and some solids hard. See, the eraser you people, you students use whenever we want to like mold them, or we can change their size, okay, according to our own will. The eraser, they are usually soft. You can think about cotton, they are soft, right? But like your pen, we usually change their, right? We can't change their size by our own hands, right? By change their size, right? So why these things are happening? Some solids we can change their shapes or sizes, but in case of some other, we are not able to change their sizes, isn't it? So there is this question is here is some solids soft and some solids hard. Let's see, let's try to find out the question. For in her mind also, she got some idea to check something. What is it? She took some substances and started to hammer them. In the first case, he started aluminium plate, then one key made of metal, and see, is there any kind of change in their shape? Next is this wood piece. So hammering it and nothing happened, no change in shape, right? In the fourth, she is hammering one stone. Shape she it got, or it became smaller in pieces, right? It broken down into smaller pieces. And there is this last iron nail. So all these things, the piece of aluminium, then key and wooden block, stone, after that rock salt, iron nail, all of these, they are solid particles, isn't it? Which object has particles held together very strong? Can you tell me? All of them are solid particles, right? But which of them, the particles which they are constituting, which particles are together very strongly? Can any one of you tell me? Let's try. See what happens in case of here, isn't it? This it is having shape, isn't it? This we can say that solids have a definite shape. And of solids and particles, they are held together very closely. Okay. And solids have a space that object is occupying. Okay. So solids occupy a certain amount of volume, certain amount of space they capture. So that means they have volume. Clear everyone? They are or closely packed together. Solids are closely packed together, like as we can see in the picture. See, all the constituent particles, they are vibrate. Particles is in to and fro. They can't move so much far from each other. Okay, they have to stay in a close proximity. So, because one strong attraction force between them, the particles are held together or packed together closely because their attraction force or the force of attraction which is acting between them is very strong. Okay, they can only vibrate to and fro and can't move from their place. Okay, that is why they have a definite shape. And force of attraction between the particles are very strong. So see, one thing you should remember that solid particles have the strongest attraction force. Like in between, if we compare gaseous substances, liquid substances and solid substances, the particles of solid substances will have the highest amount of attraction force between them. Clear? So, here also the force of attraction between the particles are very strong. In case of which substance? Very good, solid substances, right? And now there is this one question, that is there any way to make the particles in a solid move apart? Can we make somehow, is it possible to make the particles move apart from each other? Can any one of you tell me? Then let's see how to change it. See, there are some ice cubes and we are putting them in a beaker. And now see, ice is what? Ice cubes are solid substances. So the particles in ice, they are closely packed to each other, right? But if we heat them, see, we started the fire, and when we started to heat the ice, what happened? The ice started to melt, isn't it? This thing, it is known as the melting point. Okay, see, so when the particles of ice started to melt, what happened? The particles of the ice far from each other. So that led to the formation of water from ice. Okay, so when a solid is heated, its particles vibrate faster and move further apart. Okay, so what happened? We heated the ice, and what happened? The particles of ice, they started to move apart from each other, and due to this, the ice which was solid became water which is liquid. Okay, so everyone note down that what is melting point. What is it? The melting point is the lowest temperature at which solid changes into a liquid. Okay, so the lowest temperature in which a solid substance transforms into a liquid. Like as we can see in case of ice, whenever we heat the ice, what happened? The ice melted and became water, which is a liquid substances. So here we observe the change from solid substance to liquid substance. Clear everyone? Now we will observe the melting point of different substances. So first we are observing melting of ice. So like earlier, we ice cubes on a beaker and started to heat them. And at what temperature the ice started to melt? What is written? Yes, 0 degrees Celsius, right? Now, second case is melting of wax. So, we are taking some wax and similar to earlier, we also heating them. And what happens whenever they are started to melt, right? The solid wax started to melt and became liquid whenever we started to heat it. And everyone notice at what temperature it is melting? What is written? Very good, 50 degrees Celsius. So earlier we saw the temperature was 0 degrees Celsius and now the temperature is 50 degrees Celsius. Right. So there are difference in temperatures. Why is it? Because some solids have weak forces of attraction between their particles. So they have low melting points. Okay, so in earlier, what happened? The temperature was low, like 0 degrees Celsius, but still the ice started to melt. So, from this we can say the attraction between the particles was low. Okay, so that led to the low melting point. Okay, so some solids have weak forces of attraction between their particles. So, they have low melting points. Similarly, in the second case, the temperature was a bit higher, isn't it? This is why, because strong forces of attraction between their particles. So they have high melting points. Okay, so in case of wax, we can conclude that the attraction force between the particles of wax was a bit stronger. That is why in the case of the temperature was higher. First it was 0 degree, then it became 50 degree. Right, so 50 degree much more greater temperature than 0 degree. So that means they have higher melting point. So higher 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 attraction force. I hope all of you got it. Now we will be observing some melting points of some solids. Okay, so first one is ice and its melting point is 0 degrees Celsius. Second, there is urea and its melting point is 133 degrees Celsius. And third is iron and its melting point is so high. See, 1538, 1538 degrees Celsius or 1538 degrees Celsius is its melting point. Okay. So, here comes our second question. Let's see. The scientist known as the father of atomic theory in ancient India is, four options are there. Option A, Aryabhatta. Option B, Charaka. Option C, Sushruta. Or option D, Kannada. Now I am giving you the timer. Everyone try to answer, okay? I am telling you the question again. The scientist known as the father of atomic theory. Father of atomic theory in ancient India is, which one is it? Is it Aryabhatta, Charaka, option C Sushruta or option D Kannada? Which one will be the right answer? Tell me. Wow, very good. So many of you have given the right answer. Try to answer everyone, okay? We have just read it about it. Which scientist has the atomic theory in ancient India? Which scientist? Is it Aryabhatta, Charaka, Sushruta or Kannada? Which one will be the right answer? And your time is up. Let's see how many of you have given the right answer. Very good. So many of you have given the right answer. So our right answer will be Acharya Kanada. Right. So he was the one who invented or concluded, like observed, that every particle is constituted with very small tiny particles, which he named them as Paramanu, isn't it? So the scientist known as the father of atomic theory in ancient India will be option D, Kanada. Clear everyone? Very good. Now we will be observing one small activity. See, there are 3 utensils and 1 jug of water, and in the each utensil they are named A, B, C, and there are one specialty in them also. See, there is one particular mark in every utensil, and which is marking 200 ml. Okay, so he first poured 200 ml of water into the first pot, okay, which was A, and from A he poured to pot B, and there also the mark was, or the level of water was touching 200 ml. And in case of the third one, like in the pot C also, the marking which was hitting 200 ml, the water level was similar to that, right? See, if we want to like examine, then we can easily observe that the water particles are arranged in some kind of like this manner. Like in solid, we observed that the particles were closely packed with each other. But in case of liquid, what? There are too much gap present in between the particles, isn't it? In case of solids, we observed that there is no space between the particles. But in case of liquids, we can observe that the distance or gap between the liquid is much more greater than solids, isn't it? So from this activity we did with ABC pot, we observed that in each case the water level was matched with 200 ml. In case of A, B, C, the amount of water remained constant. Okay, like in every pot, the marking was indicating 200 ml. In that, on all those cases, the water level was same, which was 200 ml. So from this we can say liquids have a definite volume. See, in every case, the water level was 200 ml. First, the boy did what? He poured some water up to 200 ml into pot A. From pot A, that water of pot A, pot B, and the water this time also, like in case of pot B, this time also the water level was 200 ml. Next case also, in case of pot C, similar thing happened and the water level was matching 200 ml, isn't it? So in each case, in every case, the volume of the water was 200 ml, right? As we know, volume is what? The space occupied by a substance. So in each cases, we observe that water is occupying a certain amount of volume, which was 200 ml in each case. So from this we can say that liquids have a volume, isn't it? And liquids have no fixed shape. In case of solid, we can say that solid shape. But in case of, we can't say that, because liquids, they take the shape in whatever container we put them, isn't it? If we are putting them in a glass, they will take the size or the shape of that glass. If we are putting water water into a bottle, the water will take the shape of that bottle, isn't it? So, liquids have no fixed shape and take the shape of the container. Clear everyone? Why? Because why these things happens? Because particles of liquids are free to move. As there are lot of distance or the attraction force is not that much higher like solids, the particles of liquids, they can freely move. So that is why they don't have a definite or fixed shape. Clear everyone? Now another activity. See, the is pouring one glass of water into a big pot, and whenever he is dipping his finger into the water, like we can dip our finger into the water, right? There is no barrier between it, isn't it? Whenever he is enter his finger into the candle, he is unable to do that, isn't it? But in case of he is easily able to dip his finger into it. Why these things happens? Because in case of solid, the particles are very closely arranged and there is no space present in between. But in case of liquid, attraction force is lesser than solids. So, and they are also move easily. So, whenever we are trying to dip our fingers into the water, they can easily move from that place and they can give space for the finger we want to dip. Okay, so there is this one another information. What is it? That interparticle attraction is slightly weaker than in solids. In case of liquids, the interparticle attraction is lesser or weaker than solids. Now we will be observing another case. See, the water is boiling and what happens? That the particles of water, they get detached from each other and they become water vapor like this. See, their attraction force is much weaker than liquids also. So the weaker the bond becomes, the particles also move apart from each other. Okay, the more the attraction force, particles come closer to each other and the less the attraction force is, the particles move away from each other. Clear? So in case of gaseous, the attraction force is very much low. Okay, like lowest. And the temperature, this temperature where the water starts boiling and become water vapor, it is known as the boiling point. Okay, so note it down everyone. What is boiling point? Boiling point is the temperature at which a liquid changes into vapor. Liquid. Okay, so this is known as boiling point. What is it? That boiling point is the temperature at which a liquid changes into vapor throughout the liquid. Clear everyone? Then there is another case which is known as evaporation. So what is evaporation? Note down everyone. Evaporation is the process in which a liquid changes into vapor from its surface at any temperature. Okay, evaporation is the process in which a liquid changes into vapor from its surface at any temperature. So in case of boiling point, we need to heat the water. But in case of evaporation, we don't have to intentionally give heat to that solution or water. See, if you put one bowl of water for some days, what will happen? The water will disappear. The water level now become lesser than earlier. Why this happens? Because water water vapor, which is known as case. In case of evaporation, we don't have to heat them. They will automatically become water vapor. So this phenomena is known as evaporation. Clear everyone? Okay, so here comes our next question. Let's see what the question is. That when ice melts into water, what happens to the attraction between its particles? Four options are there. Option A, it becomes weaker. Option B, it remains the same. Option C, it becomes stronger. Or option D, it disappears completely. I have started the timer. Try to answer everyone, okay? So, when ice melts into water, ice is solid and water is liquid. So, when ice melts in, what happens to the attraction between its particles? It becomes weaker, it remains the same, it becomes stronger, or it disappears completely. Which one will be the right answer? Tell me. What happens when a solid becomes liquid? What happens? The bond or attraction force between the particles, does it become weaker or remains the change or becomes stronger? They completely, or the attraction force between them, it completely disappears. What happens? Tell me. Very good. So many of you have given the right answer, and with that your time is up. Let's see. Very good, very good. Okay, so our right answer will be it becomes weaker. Why? As we can say, or as we can know, that solids have the strongest attraction force between the particles, isn't it? So ice is solid. So when ice melts into water, the particles, they become a bit far or distant from each other, isn't it? So that leads to lesser amount of attraction force between them, isn't it? So from this we can say that the right answer will be option A, it becomes weaker. Clear everyone? Now let's see another thing. See, there are smoke and we collected the smoke into a glass jar, and there is another glass jar, and whenever we are connecting those two glass jars, the smoke, it is getting shifted into the both jars, isn't it? Why? Because in case of gaseous substances, the particles, they are more distant from each other. They are in case of gas, the attraction force is more less than liquid. Okay, the lowest attraction force, as we can see in gaseous substances. So before that, before going to discuss our next topic, there is one safety measure, which is be careful while using solid iodine. Vapors of iodine can cause irritation. Okay, we have to be careful before using solid iodine. So there is this iodine which is inside a glass jar, and from that gaseous iodines are forming, and whenever we connect the two glass jars, similar to earlier, the glass jars also filled up with the gaseous iodine with it, isn't it? So from this we can say that gases do not have fixed shape or volume, and in case of gas, particles move freely. Hence, interparticle attractions are very weak. In case of gases, the interparticle interactions are so much low. So first comes solid, they are the strongest bonds have, then comes liquid, and after that the lowest attraction force we can see in gaseous substances. Okay, clear everyone? So that's it for today. I hope whatever we have studied today, you got all that things. Okay, so till then, stay happy, Stay healthy. Bye bye.